Hello all. In today's class, I'm going to discuss about variables and data types. Okay. Let me start with the data types. Data types will tells two things to the compiler. Okay. Data types tells two things to the compiler. One is size of the value which we can store, and the second one is the type of the value which we can store. Okay. It gives the size, what amount of data we can store, and what type of data we can store it inside the memory. Okay. So data type defined as the data storage format that variable can store a data to perform specific operation. Okay. It tells the size of the data as well as it tells the type of the data which we can store it inside the program. Okay. There are basically four data types. Okay. One is int, one is character, float, and double. Okay. In these four data types, there are subdivision also. We'll see that. Okay. The first one is integer data type. Okay. Integer data type allow variables to store only numerical values without any decimal point. Okay. It allows only numerical values without any decimal point. Okay. The keyword to define the integer variable is int. Okay. I can define something like this: int followed by the name of the variable. Okay. So this is the type of the value which we can store. Next, the size of the value. Okay. The storage type size defined by the integer variable is either 2 bytes or 4 bytes. Okay. It actually depends on the type of the processor or type of the system. Okay. If the processor is 16-bit processor, then the integer data type size will be 2 bytes. Okay. If the processor is 4 bytes, that is 32-bit processor, then the integer size of the integer data type will allocate is 4 bytes. Okay. So it's totally depend on the type of the processor or type of the system you have. Okay. So integer is a data type. The short form is int. Int keyword can be used to create an integer variable. It allows only numerical values to store without any decimal part. Okay. And the storage size allocated by integer is depends on the system, either 2 bytes or 4 bytes. Okay. The next one is character data type. Okay. Character data type, it will allocate 1 byte of memory. It will allocate 1 byte of memory. Inside each character, we can store only one character. We can store only one character. Character can be anything. Okay. It can be alphabets like A, B, C, D. It can be numbers, or it can be a special symbol also. Okay. So this is characters. Okay. It can be alphabets. It can be numbers, or it can be a special symbol also. Okay. The size is 1 byte. Okay. The keyword to create the character data type is char. Okay. And the type of value which we can store is only one single character. Okay. While storing, the character must be stored within the single quotes. For example, if I take a variable character A is equal to, if I want to assign value to this A, the value must be present within the single quotes. I can store the value called X. Now, A is a variable which contains the value called X. A data type is character. So character means A can contains only any character, single character. As I told, the character can be alphabets, or it can be numbers, or it can be symbols. Okay. Size is 1 byte, value is single character, and that single character must be present within the single quotes. The name of the data type is character. Next is floating point data type. Okay. Floating point, it allows number and decimal part also. Okay. We can store the numbers with decimal part. Okay. For example, 2.5, 7.8, 9.6123, something like this. Okay. If it is an integer, it will allow only numerical part, but it won't allow decimal part. Okay. But in case of floating point data type, it will allow decimal part also. There are two types of floating point data type. One is float and other one is double. Okay. The only difference between float and double is after decimal point, how many digits or what is the precision we can store, how many digits we can store. That is the difference between float and double. Float has less number of decimal part, I mean the length of the decimal parts will be less, but double has more number of digits we can include it after decimal point. Okay, so float allows variables to store decimal values, as I told. Even double will also store same thing. Okay, the major difference is double data type allows 10 digits, up to 10 digits after decimal point. Okay, it allows up to 10 digits after decimal point. In case of floating point, it allows up to 6 digits. Okay, so other than that, I can create a floating point variable something like this, float x, and double. I need to use the keyword called double itself, double something like this. Here x and y's are variable. X can contain floating point value, I mean decimal point up to 6 digit, and y can contains double value, I mean a decimal point up to 10 digits. And there is a size variation also. Float will allocate 4 bytes of memory. Float will allocate 4 bytes of memory, and double will allocate 8 bytes of memory. Okay, it will allocate 8 bytes of memory. That is floating point data type. Okay, next we'll discuss about variables. What is variable? As I discussed in the first session itself, variable is just a name given to the memory location. Variable is just a name given to the memory location. Okay, variables can contain numbers, it can contain alphabets, okay, and it can contain some symbol also, I mean limited symbols like underscore, something like that. Okay, so variables declaration as some condition, the variables must start with letters, I mean alphabets. It must start with letters or it must start with underscore. Okay, so letter followed by or underscore followed by any number of alphabets, any number of alphabets or any number of digits. Okay, so variable must start with the alphabet or letter, or it must start with the underscore symbol. Okay, followed by it can contain any number of digits, numbers, or it can contain any number of alphabets. Okay, there are some limitation to the length of the variable. Okay, some system will allow up to 32 digits, up to 32 characters. Okay, variable length can be up to 32 characters. Okay, so variable composed of letters, digits, and underscore character. Okay, as I told, it must be begin with either letter or underscore. Okay, in C language, the variables are case sensitive. The capital letter A is not same as small letter a. Okay, if I say int a, it is totally different than integer a. Both are integer variable, both can contains value, but both are pointing to different memory location. Both are pointing to different memory location. So variable declaration, as we discussed while discussing the data types, a variable declaration will be something like this: data type followed by name of the variable. Name of the variable. This is variable name. Okay. So what happens if I declare the variable? For example, if I create a variable like integer a. Okay. Assume that the system is 32-bit processor. Okay. Inside the memory, one block of memory will be created with the size of 4 bytes. With the size of 4 bytes. Okay. As we discussed earlier, the data type will specify two things. One is size of the value or size of the memory location, and the type of the value which we can store. Okay. So int will allocate 4 bytes of memory, that is 32-bit if I'm talking in terms of bits. Okay. And here a will be the name of the memory location. A will be the name of the memory location. This is the memory location. The size of the memory location is 4 bytes. Okay, and the name to identify this memory location is A. Okay, I can store the value also. If I store something like this, A is equal to 20, this 20 will be put it inside this created memory block. Okay, now A value is 20. Okay, hope you understood. Like this, all the variables will create the memory block. The size depends on the specific data type, and the kind of value, it also depends on the specific data type. Okay, I'll give one more example. If I take character data type, character something like, I'll take character X. I'll take character X is equal to, within single quote, I'll store something like B, semicolon. Okay, what character X is equal to B, it means it will create a memory block. Since character will allocate only 1 byte of memory, 1 byte of memory will be created, and the name of this memory location is the variable name, that is X, and the value for this variable is B. So character data type means it will contain single character. Okay, like that, even floating point and double will also allocate the memory, and it will store the values. Okay, there are two ways to initialize. I can initialize in the same line. For example, something like this, int A is equal to 20, or I can split it into two lines, int A semicolon. In the next line I can put A is equal to 20. Okay, this entire thing is equivalent to this one, int A is equal to 20. I can initialize directly, or I can initialize in the multiple lines. Okay, and one more important thing is I can define multiple variables in a single line, A comma B comma C. I defined here 3 variables. I can initialize these 3 variables in the separate line, or I can do it in the same line also. Int A is equal to 10, comma B is equal to 20, comma C is equal to 30. This is also possible. Okay, variables can be initialized in the same line, or it can be initialized in the different line also. Like this, I declared 3 variables ABC, but I'm initializing in the separate line, something like this. Okay, like this I can also initialize for the character variable, character data type, as well as for the floating point and double. Okay, so in today's class we discussed about 2 things. One is data type, that is major data types are integer, floating point, character and doubles, and variables. Variables is just a name given to the memory location. Variables will have 2 parts, declaration part and initialization part. Declaration means identifying the data type of the variable, and initialization means storing the values. Okay, now we'll see the example for this. Okay, we'll see the example for what are the data type we studied in today's class. Okay, you can see it in the program. Okay, this one is a preprocessor directives. The next one is main function. Every program must have at least one function, that is main function. This is the signature part of the function, and declaration part starts here. Okay, I'm declaring 4 variables, that is int A, float B, double C and character D. In the same line itself I'm initializing the value. A, it contains only numerical value, that is 10. Float, I'm storing the numerical value with decimal part, that is decimal numbers, numbers with decimal point 2.5. Double with more precision, I mean more number of decimal parts can be added, up to 10 digits. Here up to 6 digits I can add. Okay, the value of double is 3.002. And character, it can store only single character. I'm storing here X present inside the variable called D. Okay, you can observe here, while printing the 4 values, integer, floating point, double and character, see the syntax. I'm printing some message like integer value equals followed by some character like percentage and D. Okay, you can see it in the next line, percentage and F, percentage and LF and percentage and CF, percentage C. Okay, these are all called format specifier. These are all called what? Format specifier, where percentage D is a format specifier. It is used to print integer numbers, percentage D to print integer number. Just to identify what kind of value I'm printing, I need to use, or I need to specify format specifier inside the printf function. Percentage D to print the integer number, percentage F to print the floating point number, percentage LF to print the double, and percentage D to print the character. Okay. Now we'll execute this program, we'll run the program and see the output. Okay. Here the only printable statements are, only printable statements which is present inside this printf statement, that is int value is equal to value of this integer variable. And you need to observe one more thing. Here the percentage D will be replaced with value of A. Okay, percentage D will be replaced with value of A. Percentage F will be replaced with value of B, that is 2.5. Percentage LF will be replaced with value of Z, that is 3.002. And the percentage C will be replaced with value of D, that is X. Okay. We'll compare the program and output. Okay. See, it's printing integer value is equal to 10. Okay. Why it is printing float value is equal to 2.500 in the next line? Because after first printf statement I included /n here. Okay. /n will include the new line. So next printf statement will print the statement in the next line itself. Okay. So float value is equal to 2.50. Double value is equal to 3.002. It is rounded off to up to 6 digit. It is rounded up to 6 digit. Even double also. But if I give more length, something like 3.002 to some up to 10 digit, it will print all the 10 digit. If it is not, it will round off to up to 6 digit itself after decimal point. Okay. And the character value, you can compare the input and output. While storing the value, I put it inside the single quotes. But while printing, it's not printing the single quotes. The single quotes will be removed. Only the value of that variable, that is value of the D, will be printed, that is X. Okay. Thank you.